In this video, I'll show you how to solve the ALEKS problem called determining the molar mass of an acid by titration. So as you probably know, the molar mass or molecular weight of a substance is just the grams per mole of that particular substance. In this case, we're dealing with an acid. Now this ALEKS problem is going to give you the mass of a particular sample of this acid. So we already know the grams of the acid. We just need to figure out how many moles there are in this 0.087 gram sample, or whatever the mass is for your particular acid. Now, one of the things that ALEKS is going to tell you in this problem is going to describe the acid as being either monoprotic, diprotic, or triprotic. Pay attention to that. That's going to be really essential information. We'll need to use that while we're solving the problem. So as I said, the number of grams of the acid is given to you in the problem, and our job is to figure out how many moles of acid we have. And we're going to do that by doing a titration calculation, which is just a fancy type of stoichiometry. And when we're doing stoichiometry problems, the very first thing that we need to do right off the bat is to write a balanced equation for the reaction that is taking place in this titration. Now, it's a little bit tricky to do because we don't know the actual acid, so we really technically can't write a balanced equation, but we do know in a titration reaction that we have an acid reacting with a base. In this particular problem, the base is NaOH, and I flipped through a few different ALEKS problems, and it was using NaOH as the base every single time. Maybe there might be some problems that use KOH or LiOH instead of NaOH, and if that's the case, don't even worry about it. KOH, NaOH, LiOH, they all react the exact same way. So if we know in this titration reaction, if we have a monoprotic acid, so I'm just going to rewrite this. If we have a monoprotic acid, monoprotic means that the acid has one acidic hydrogen, mono being the prefix for one. A monoprotic acid is going to react in a 1-to-1 ratio with the base, NaOH. That is going to be the stoichiometry for the reaction. It is possible that you might have a diprotic acid in your ALEKS problem. And a diprotic acid, di means that it reacts 2 times with the base, with the NaOH. And there are also some triprotic acids in this ALEKS problem, so you might have a triprotic acid as well. Tri, the prefix for 3, it means that that acid reacts with 3 equivalents of the base. So what you're going to need to do is take a look at what type of acid ALEKS has in the problem, and you're going to need to choose the correct equation with the correct stoichiometric coefficients in order to get this problem correct. Now remember, our job, what we're working on right now, is to figure out how many moles of acid we have, and the way that we're going to do that is by calculating the moles of NaOH, and then using stoichiometry to convert that into the moles of acid, because we know the stoichiometric relationship between the acid and NaOH. Even though we don't know the actual acid and we can't finish this equation, we can't finish it and balance it, we do know that the NaOH reacts with the acid in a predictable way based on whether the acid is mono, di, or triprotic. Now, the problem is not directly giving us the moles of NaOH. It is giving us instead the volume and the molarity of NaOH. So for me, I have 14.4 milliliters and 0.07 molar. So we're going to use the volume of the NaOH, and we will convert the volume of NaOH into moles, and then convert the moles of NaOH into moles of the acid, and then we're going to plug that into this equation right here. Okay, so let's start with these calculations. My volume of NaOH is 14.4 milliliters, and we are going to need to, right off the bat, we're going to need to convert that out of milliliters and into liters, and I'll show you why in just a second. Milli is the prefix for 10 to the minus 3, so 1 milliliter is 10 to the minus 3 liters. That's going to cancel that unit. The next thing that we're going to do is convert from volume into moles. Now, the conversion factor that we use to go between volume and moles is the molarity. My solution has a molarity, that's this one right here, of 0.0700 molar. That means specifically 0.0700 moles of whatever the substance is per 1 liter. And for mine, it is moles of NaOH. Now, this relationship can be used as a conversion factor to convert between moles and liters. In this setup down here, we're trying to convert out of units of liters and into units of moles of NaOH. So when we're using molarity as this conversion factor, we're going to have the the molarity, which for me is 0.07. I'm going to leave those last two zeros off to save space. 0.07 moles per liter. That's going to cancel that unit. And right now we have finished this part of the conversion and we're in moles of NaOH. Our last step is to convert out of moles of NaOH and into moles of acid. And to do that, we're going to be using the stoichiometric coefficients from these equations right here. Now remember, you're going to have to choose based on what type of acid ALEKS is giving you in the problem. If you have a monoprotic acid, that's a 1-to-1 relationship. If you have a diprotic acid, it's 1-to-2, etc. So for all of these, no matter what type of acid you have, the stoichiometric coefficient for the acid is always 1. You're going to need to choose the correct stoichiometric coefficient for the base, depending on which of these equations you're using. For mine, because it's monoprotic, I'm using this equation right here, and the stoichiometric coefficient for NaOH is 1. And that's going to do that. And so we are ready. We have everything set up to calculate the moles of acid. So we're going to go ahead and carry the math out on this. 14.4 times 10 to the negative 3 times 0.07 times 1 divided by 1. This gives me 0.001008 moles of acid. Now remember, our goal here is to calculate the molar mass, which is the grams per mole. So we need our grams of acid divided by the moles of acid. And we just figured out the moles of acid. The ALEKS problem is going to be giving you the mass, the grams of the acid. For mine, it is 0.087 grams, and I'm plugging in the moles that I calculated, 0.001008. One last step, 0.087 divided by that answer above is 86 grams per mole. ALEKS wants this one to 2 sig figs, so my answer is just 86.